We have an application question which is asking us about moving some parcels with big or small vans. So what we're going to start off by doing is we need to label what are big vans and what are small. So let's say X are large vans and Y are small vans. That's now going to help us create our equations. Now, first of all, we know that a large van can take 150 parcels and a small van can take 60 parcels. So we'll start off by saying, first of all, that if I take 150 parcels in a large van and 60 parcels in a small van, each time I take those parcels in one of those vans, that will add up, and so I can use this as an equation, and I need to take 900 or more parcels. So if I work something out and I'm taking 950 parcels, that's okay, but I need to make sure it's at least 900 parcels. So that's the first one. The second constraints I need to think about are, I need to have a positive number of vans. I can't use a negative number of vans. That doesn't make any sense. So my X is greater than or equal to 0, and my Y will be greater than or equal to 0. So now I'm saying I have a certain number of vans and they take a certain number of parcels. The last thing is I need to concern myself with the price as well. So here I have the cost of each journey of 5 large and 4 for a small. So my cost constraints will be that 5 times every large van plus $4 for every small van needs to be less than $44. It's not allowed to be less than or equal to. It must be less than $44. So now I've got 4 equations that I need to graph, and I need to start looking at the feasible regions. So now let's have a look at our equations and how they'll end up looking on the graph. So first of all, my X is greater than 0 and my Y is greater than 0. So what that means is for my axes, my Y's are positive and my X's are positive. So let's rule them in now. And now they're there. Let's turn our equations into equations that we can actually use for this. So we've done my X is 0, we've done my Y is 0. Now let's do this one. 150X plus 60Y is greater than or equal to 900. Remember, I'll go here and I'll type it in. 150X plus 60Y is greater than or equal to 900. Remember, in my keyboard, I'll go to Maths 3 and get my greater than or equals to 900. Then I highlight that and I'll go interactive and I'll do equation inequality and solve, and I do that for Y. So anytime I want to express something in an mx plus c format, I'll solve for Y, and it doesn't like it. Now what this means is that somewhere in my calculator I've already calculated values for X or Y. So it means I need to reset the calculator completely. So I'm going to clear all the variables and I'll try it again, and suddenly I get an answer. So this says that Y is greater than or equal to this whole expression here. Let's see what happens if I go to standard. It might look a little bit neater, and it does. So I'm going to get this number, and I'm going to copy it and move over to my graph area, menu, graphing and table, and drop that in there. So there's my first equation that I've dropped in. My second equation, so remember, this one's now done, and it's going to be Y, let's do this one in blue, because it's a blue one on here. It'll be Y equals negative 150X minus 900, all brackets, over 60. And now for my second equation, this one here, let's do this one in an orange colour. 5x plus 4y is less than 44. I'm going to go back to the main. I'm going to say 5x plus 4y is less than 44, and I'll highlight that, do the same thing, interactive equation, solve for y, and I get y equals this, so y is less than negative 5 blah blah blah. So I'll write that down here. y is less than negative 5x minus 44 over 4. And I'll highlight this and I'll take it over to the graphing section. And now I have my two equations in there. But I've got these equal signs, remember? So I need to make sure that I have less thans. The first thing I'm going to do though is I'm going to sketch each of them so I know exactly where they appear on my graph with their intercepts. So here we go. My first one I've ticked, I sketch, and it puts this line in. Now it looks like my intercept's up here somewhere. So what I'll do is I'll double check by zooming out, and I see that my graph looks something like this. So let's get our x and y intercepts going. Analysis, G-solve. My x-intercept is at 6 and 0, so I'll make a note of that on my workbook. So I know here the x-intercept is at 6 and 0, and my y-intercept, if I go analysis, G-solve, y-intercept, it's at 0 and 15. So I'll write here 0 and 15. So I know they're the important features of this equation. For my equation down here, I'll do the same thing. I'll say my x-intercept, so when I sketch that, that's my other line. X-intercept, G-solve, root is 8.8 and 0. So I'll write down here 8.8 and 0. And my y-intercept, analysis G-solve, is 0 and 11. 0 and 11. So there are my important points there for this line. And lastly, let's find out where they intersect. So then I can draw two lines, analysis, G-solve, intersection, and that tells me the intersection is at 3.2 and 7. So I'm going to write that separately. 3.2 and 7. So now I have all the important information I need for these lines. So let's sketch them. So now you can see I've sketched my graphs and I've put in all the important points. And the last thing I need to do is represent the feasible region. So now that I've done that, it's time for me to change my signs so that they are appropriate. Remembering when I solved this sign, 150x and 60y is greater than or equal to 900, I got y is greater than or equal to. So I need to write y is greater than or equal to that. And down here, when I solved this, I got y is less than, so I've written y is less than. So now I go over to the graphing section. And in the graphing section, I'm going to change my signs so they're appropriate. The first one is greater than or equal to. The second one is less than. And I'm saying OK. And now when I sketch these, I can see that my feasible region is the region down here. So this is where I need to be focusing. So I'll just try and cut, whoops, I didn't mean to colour that line in. I'll just try and colour this in a little bit so we can see that this is my region, that's my feasible region for this particular question. And I think I've made it pretty clear where that zone is. So that's part A done. Now to answer part B, what I need to do is I need to have a look at all the possible values of x and y using this diagram. So I hope my diagram's neat, but it's possible that it's not absolutely perfect. And that's one of the problems with graphical solutions, that you have to be absolutely perfect. So what I'm going to do now is I'm going to blow this graph up so that I get to see what possible values I might have. So now here's my graph shown in much bigger and possibly uglier way. And now what I want to do is I need to show every possible point with an x. Well, I need this point because that's a possible value. This is a possible value. This is a possible value, and so on. Because the only values that are possible involve whole trucks. I can't send half a courier truck to get stuff done. So there's a point and there's a point as well. So it looks like where I have the crosses are the only valid spots. Now, one of the problems is that my lines are quite thick. It's possible that I have a valid spot here as well. It's possible that I have one here. But using my graph, this is the best I can do. And an examiner would understand that when you're going with just a graphical solution, that may be the best possible answer. Now, the final question, as you can see here, asks for the largest number of vehicles that could be used or the smallest number of vehicles that could be used. So let's go and have a look at our graph and see what we can come up with. Now, if I'm looking at the largest number of vehicles that can be used, I want the maximum value. So I'm going to have a look at which points give me the maximum value. For example, if I had a look at this point here, this has 5 small vehicles and 4 large vehicles. So this point here is 9 vehicles. If I have a look at this point, there's 4 plus 5, so this is also 9 vehicles. This one is 6 plus 3, 7 plus 2, and so on. So the largest number of vehicles is 9, and that would involve 5 small, 4 large, 4 small, 5 large, 3 small, 6 large, 2 small, and 7 large, or thereabouts. In the same way, we can find out what the smallest number of vehicles used are by having a look at some of the points on this side. Here I would have 5 large vehicles and 3 small, so that gives me 8. Here there's the same. Here I have 6 large and 1 small, so this one gives me 7. But this point here tells me if I had 6 large and no small, that gives me the smallest number of vehicles I could possibly use. So in this way I can maximize my vehicle usage or minimize depending on what I wanted to do.